Good morning, good afternoon, good evening for people from different parts of the world. It's a lecture of the CRE, the Collective for Reimagining Engineering and Innovation. Today we have Professor Joerg Schulz from the Friedrich Alexander University. He holds the chair for electron devices at that university, and he is also connected to the Fraunhofer Institute in Germany, which is an industry, academy, and government collaboration. And I think what he has done in building this Bauhaus to microelectronics is a remarkable story of looking back to the future, in a way, looking back and going to the future as a way to think about design education in the context of electron devices. I won't take any more time, and I will hand over the mic to Joerg. Thank you very much for giving this lecture.
I thank you very much for the kind invitation. As I already mentioned in our little introductory round, it's now my first time that I have the chance to present my ideas on the connection between Bauhaus and microelectronics education to an international audience. And I'm also very interested in your feedback on that, because this keeps me now busy since 2019, the 100th anniversary of the Bauhaus, where this was mainly the time I was stumbling over the Bauhaus. And here, since that, I'm hooked. And meanwhile, I read, I would say, a meter of books on that fascinating story. And I think more and more, the more I introduce that also to my work with my students here, I think the more successful we are here. And I want to give you a little impression and insight in our work on Bauhaus and microelectronics. By the way, I have presented a presentation in all 98 slides. And of course, I do not have the time to show you all the slides. If you like, I would love to share the slides finally with you. I'm pretty sure my slides are self-explaining because I have a lot of text coming from Gropius itself, that you afterwards maybe have the chance to read it in more detail. So in my 45 minutes I have now here, I want to more or less guide you through the ideas. Later on, you then can look in greater detail too, if you are interested in. Maybe I start with the problems I see in especially MINT education, so mathematics, informatics, natural science, and technology. So that is for us very, very important. And I'm pretty sure most of the problems we have here in Germany are more or less problems of the whole world. But my experience is coming from Germany. So that's why allow me to give you some impression what problems we are facing in our academic MINT education, and also to explain you a little bit why I'm on the seek how to train and attract young people for microelectronics, for electrical engineering. And here just some bullet points of problems we are facing. So one statement we permanently hear in Germany is that, for instance, lecture is not the right form to present ideas and topics to modern students. We have to do something completely different. But more or less, if you ask, okay, what can I do instead? At the final end, we are ending up again with lectures. But permanently, so that's why I gave the headline, the lecture is dead, long live the lecture. But permanently, and this is also my experience in 25 years, that permanently I was given the information, you have to do something different. Lecture is not the right way of doing that. And then the question, of course, is if you have 200 students in a beginner course, okay, what else I can do instead of a lecture to give the message to the students. Then, of course, one big problem is, and this is very similar to the situation Gropius found 100 years ago, that here in Germany, the universities are still too overheaded, or at least that is the statement about the university academic training itself, and has too little practical relevance. And you know, in Germany, we also have a lot of technical colleges, And very often you hear in Germany the statement, okay, if you really want to go or work in industry, you have to study more or less on the technical college and not went to universities. So, and due to the fact, and if you look to Erlangen, for instance, we are around about 35,000 students. So, and this is a mid-sized university we have in Germany. A lot of universities are much bigger than we, for instance, are. So, and then you know that very often we face the problem of the felt distance between teachers and students due to the mass university, the given anonymity, the loneliness of the students, so the lone wolf. So that is also mentioned as problems of our academic education itself. And then this is also, I had a lot of discussions with my students, and some of them, and I have no clue how big that fraction finally is that sometimes our students have the feeling that especially the researching professors are not really that much interested in training their students. They are interested in their research, and more or less the giving lectures, especially the basic lectures at the beginnings, are more or less a burden to them. So they are not that much interested, it seems. So, and that is still a big problem we are facing since at least 20-25 years, is if we look to the amount of women we attract in our programs, that we are well below 20%, and especially in electrical engineering, it is somehow between 10 and 15%. And since 20 years, we are talking, okay, we have to increase the number, especially of female students, because the male students are more or less in the program. We are saturated with that. And if we further increase capabilities here, we have to attract young women. And we have to face that since 20-25 years, we completely fail in attracting young women, especially in electrical engineering. So, and the problem is, even if you said, okay, at the moment we have 10 to 15% women in electrical engineering on a bachelor level, this amount is still dropping down. If we go on to the master's program or to the PhD program, then this number is further reduced. And meanwhile, and this is a very modern development we have here, that also the number of men interested in studying electrical engineering, and especially also microelectronics, starts now also to drop down. So since 20 years, we more or less had the situation that we had a constant level of interested students, male students, to study our program, but we never had a chance to increase the number of women. And now we are seeing, okay, the number of women is still small, but the number of men is fully dropping down. So, and permanently, we also have conferences, what to do to overcome this problem, to get more attention and to attract more people, and so on and so on. And I'm pretty sure I could spend the next 2 hours in discussing all these problems, and I'm pretty sure if you add also your problems, I'm pretty sure we can fill the whole day just, yeah, in sharing our visions on that. For me, this is just for you the information. I'm handling that problem, or try to handle that problem now since 25 years. And here, Bauhaus, more or less, was really an inspiration for my work. And this is mainly what I want to share with you. Because, and that was exactly in the year 2019, so it's now 4 years away, that I was catched by a broadcast event in one local TV broadcast agency here in Germany about the Bauhaus, which really hit the nerve and also impressed me very much. At that time, I was asking myself, so it was a broadcast about the women of the Bauhaus. And here the funny thing was, so I was really looking at these TV show, and I was in the situation that, first of all, I was asking myself why I'm now permanently stumbling over the Bauhaus. So in the year 2019, so it was the third time that I just turned on the TV, switched the channels, and I was in the middle of a TV show about the Bauhaus. Yeah, it took me 3 times to understand why that is the case, because here I learned, and I didn't know at that we are in the 100th year anniversary of the Bauhaus in 2019. And that's why, of course, all the TV, we had a lot of TV shows and programs on the Bauhaus itself. And that was more or less the first thing where I started really into Bauhaus. Just to give you that information, before that, of course, I had a little knowledge about the Bauhaus. Of course, I know it was a very famous architectural school. It was in the first German Republic in the time between 1920 and 1930. Some names like Walter Gropius, who founded the Bauhaus, was also known for me, but that was just it. And I had no further information by myself over the Bauhaus. And here, with these TV shows I started now to watch in 2019, I learned more or less three things. First of all, I personally have no clue about the Bauhaus. And second, I found here a very inspiring new world for me, which was completely unknown at that time for me. It's a complete new world where, and this is the interesting fact, they started from scratch in 2019. And in total, it was 14 years that the Bauhaus was existing. They created a completely new teaching and education program. And they were, first of all, and that's why here in my slide, I present one famous woman of the Bauhaus. They were also overrun by women. So they had a big attraction to young women in their program. So most of the students, they have to push back because they don't have enough place for them. And within the 14 years of existence of the Bauhaus, they created iconic work. And still now, till now, 100 years later, Bauhaus still defines what is modern art, what is modern architecture. So if you still look to the architecture and to the paintings and so on, that is still modern. So this is still valid for the 21st century, and you do not have the feeling that this is all 100 years old. And that impressed me a lot. And that's why I said, okay, I have to learn about it and to see, because, and this was also my impression I gained from these TV shows, that here in this world, maybe I can find answers to the questions I have related to my own subject, mainly how to educate and how to train young people and also to attract them. And here, especially with the respect to the women, maybe also to get some information how to attract women to the program we have. So that's why I followed a little bit the footsteps, or I walked in the footsteps of the Bauhaus in 2019. For instance, that for the first time in my life, I really visited the still existing buildings, the still existing school of the Bauhaus in Dessau. And if you come to Germany, I just invite you to visit this fascinating location where you can learn a lot about the school, the location, the people, and also the concept of the Bauhaus itself. And a fascinating story is that in the Bauhaus, the professors were not only working together with their students, they were also somehow living together with them. And this was also very fascinating. They taught their students completely new ways of architecture and construction of buildings and their own houses. And these were the master houses where the professors of the Bauhaus were living. They were constructed from the beginning in the philosophy of the Bauhaus. And what more or less they taught, they immediately realized in their own homes. And here, of course, in their homes, they also had the ateliers where they were working also together with the students. And this is just in walking distance to the school itself, where you also see that they tested on their own houses the new concepts of building itself and formed a very interesting community in their subject itself. And Sab was asking me also to add that a little bit, because we have no clue about the audience which is now listening to Bauhaus, and we are not sure how much information you all guys have about the Bauhaus, but there are, for instance, tight links between Bauhaus and India. So, for instance, if you look to the first exhibition of Bauhaus architecture and Bauhaus paintings given outside Germany, that was not in Europe or in America, that was in Kolkata. Because Rabindranath Tagore was one visitor of the Bauhaus. So before this Kolkata conference in 1922, Tagore visited Bauhaus itself in Dessau, in Weimar. And then they were invited to show some exponents here in Kolkata during the 14th annual Indian Society of Oriental Arts. At that time, Rabindranath Tagore was the guy who was heading that conference. And then, the links, especially between Tagore and also the Bauhaus guys, were kept alive also at the end or over the end of the Bauhaus itself. And here, that much better than me, Tagore also founded the Kala Bhavana Institute of Fine Arts in Bengal, in India itself. So also here, some sort of link to the Bauhaus you can still find in India. And if you look now what happened after, in 1932, the Bauhaus came to an end because the Nazi regime here in Germany was fully against the Bauhaus. So that's why they decided to stop the Bauhaus itself. And here also, and that was very sad for Germany itself, most of the brilliant guys who created the Bauhaus and who created the architectures and the arts were then leaving Germany. They spread around the whole world and took the ideas they developed in the Bauhaus, also the teaching ideas, they brought it into the rest of the world. And now you find Bauhaus, which was then created after 1933, everywhere in the world. So for instance, in Israel and Tel Aviv, in Guatemala City, of course, in the United States, but also in Japan or in Africa. If you look to Casablanca, you find that architecture. And of course, you also know, okay, Le Corbusier is not a Bauhaus architect, but he's of course linked to the community of Bauhaus. The style was very similar. And if you are interested in that very special architecture they developed and created, and you want to see it in your own country, then you have to go to Chandigarh, where, for instance, here the Chandigarh Capitol Complex itself was created exactly in the style of this modern architecture, which was also mainly influenced by the Bauhaus developments. So, on the one hand side, that was, of course, a very interesting journey, and I learned as an electrical engineer, I learned now a lot about architecture itself. But now the funny thing is, of course, that was a beautiful side effect of my journey, that I also learned now a lot of architecture and a lot of arts and culture. But during my search of the Bauhaus, I was permanently asked the question, how they did that, how they trained their students, what was the philosophy, what was the concept behind that. On the one hand side, they had an excellent theoretical education, but on the other hand side, they have a beautiful experimental education. And as I said, all of the students from the bachelor to the master's level brought out iconic work, which is still iconic 100 years later. And that was within 14 years. And that, of course, my question to find out, okay, how they did it. And the funny thing is, and that was also finally the push for me, that I said, I want to adopt these things I learned here into my own work so that I create my own microelectronic Bauhaus I'm using to train my students, to work with my students together. And the final push for that was coming here from that guy, because as I finished my PhD and started with my habilitation, I got a new office in our institute at that time. And here I found that saying on a yellowed note on a pinboard of my board. And here, maybe you know that from Antoine de Saint-Exupéry. If you want to build a ship, then don't drum up men to produce, procure wood, assign tasks, and divide up to work, but teach the man to long for the wide and endless sea itself. And what I learned, so as I read this text, and that was way before the Bauhaus, my Bauhaus time, I decided, yes, this is something I want to follow. I want to train my student in the way that at the final end, that they long for the wide and endless sea. And what I learned during my study of the Bauhaus is that I fully misinterpreted that saying for my own work. Because if you ask, I'm pretty sure if you ask my own students about my teaching and how I do my job, I'm pretty sure that they will say, yes, it is true that I attract them, that I catch them, then, and finally that I give them a vision and that they start to dream and to long for the wide and endless sea. But that was the way I finally attract them into my institute, into my chair, and started to work with them. But then I completely made it wrong, because what I did then, when they started to assign their work to my institute, then, yeah, I drummed them up a procure wood. I assigned the task and divided up the work. And the saying here is, if you teach them in a way that they long by themselves for the wide and endless sea, they will build their ships by themselves. And this is what I'm facing then as I studied Bauhaus, the fact that you don't let your students build a ship. And here I ask now the question, okay, what I have to change in the own training program, education program I give to my students, that at the final end, they are able to build their ship by themselves, and that it is not my business to tell them how to do it, that they start to train themselves to get by themselves the practical hands-on experience, that they start to build their ship alone. And I would state now that with the Bauhaus, I found a concept to make that saying really alive in my work with my students. So this is, since more or less 2019 now, my vision, that I want really to go with my students these progressive way they already started 100 years ago in a research-based teaching and practice-oriented education, that finally Bauhaus is not only a synonym for architecture and fine arts and design, but it is also, or become also, a synonym for progressive engineering work. In my case, this is semiconductor training, a semiconductor-based electrical engineering. And if you are interested more to discuss with me on the Bauhaus, meanwhile, we also have a little community founded here in FAU, and I'm the owner of that. We have these European, and you can also, as an international partner, can join our European ELISA community, where I created for us a platform to discuss in more detail about new ways in education and management by using the Bauhaus. And here on the slide, you also will find the link. So if you are interested in that and you want to learn more and have more exchange on that, I invite you to join our program. Let me talk about, so as I said, I was not only interested in, or to say it fair, I was not mainly interested in the architecture and the art. Of course, it was nice to learn about it, and I liked it and I love it, but that was not my intention, mainly to learn about architecture. My intention was to find out what is the philosophy, what is the concept behind the Bauhaus teaching concept. And here Gropius itself gave me an answer by his manifest. And Gropius itself in 1919 wrote a manifest, and if you're interested, I found a good translation into English. It is only 3.5 pages long. If you're interested, I can send it to you by PDF. And the funny thing is to learn, okay, how to write a study program, and this was more or less the only program they wrote. The major thing of the program you see on the right-hand side of my slide, that is the module structure of the program itself. And a little bit later, I will explain you in detail. I haven't translated to you guys what you can read here inside. At the moment, it's not important. The message I want to give here, I will show you in 5 minutes, the typical module structure we give to our programs in nowadays. And then you will see, if you compare that, what is the big difference between showing the program in this way and showing the program in the way we are doing it right now. The funny thing is, I'm not an architect, I'm not an artist. So that's why I could feel the situation of a student who's asking himself the question, am I interested to study that, yes or no? And the funny thing is, after reading that 3.5 pages and looking through that module program, I immediately understood what is the program behind, what is the target, and I was immediately catched. And the funny thing is that module structure was not really explained. That was self-standing. And the funny thing is, if you translate that into English, that you can also read the world, you understand the target of the study and what you have to fulfill to reach that target immediately just by showing the module structure. If you look to our modern module structures, then you will see that students do not understand. But this is what students understand. And this module structure is accompanied with 3 pages of text on a very emotional level to describe, okay, how to address the future, how to create utopia, and also to show, okay, which part of utopia you can tackle if you study that program. And the funny thing is, you see here, I'm not translated it for you, that you're not reading it, that you just have a visual impression. You see, I play here with colors. I made in minor letters, I wrote what is really related to architecture, to painting, to really crafts work with respect to sculpturing and so on. And the green words is what is true for all other subjects. And you see, I created it in a way that the bigger letters, the green letters, form a readable text. And you see, I just let some words out, but if you would read that in German, you would see that still the green one is a fully readable text. And the text itself is 100 years old, and that goes over 2 pages. And if you just would read the green text itself, that is still true for our times. This is still true for the 21st century. And it sounds still modern, even the fact that this is 100 years old. And here was more on an emotional level. So the funny thing is, I was not catched as a student. I was not catched by the words itself and by the program. They catch me fully emotional, and after reading that and looking a little bit in greater detail, I immediately decided, okay, if I would be now a young person, I would immediately go to that place and would love to study that. If you're interested, and here on the slide, you see also the internet link where you can find the Bauhaus manifest, also in the English, a very good translation into the English language. So if you're interested, I invite you just read that. This is that was the starting point of the study program. And what I learned here, and that was very funny for me, with the Bauhaus, I also got the real interpretation of workshop. If you would have asked me, please translate workshop for me. So the first time I heard workshop as an English term, that was during my PhD times. And to be honest, of course, I had the basic training in English during school times, but that I started to learn English, that I can express myself in a more complex way in English language, that was more or less during my PhD and then later on. So at that time, first I was falling over workshop as a name, and immediately I back translated that word into German, and workshop in German is Werkstatt. But immediately, if I have listened to Werkstatt, a tool shop or a garage came into my mind. So that was my first back translation of workshop. And during my PhD time, I was invited to join a workshop. And then I back translated this and said, okay, they invite me into a tool shop or into a garage. So what fancy stuff is that? And then I learned, okay, it was just a minor little conference where we all tied up and showed our slides or showed our presentations. That was a workshop. And later on, also in my professional lifetime, then workshop was just a little conference. The only difference was at the beginning, I had to show transparency slides. In modern times, I just click in my laptop and show my PowerPoint presentation, but it is a workshop. And the funny thing is, I learned that, yes, the original word of workshop is the Werkstatt, the German word Werkstatt. And the Bauhaus students, as they went out of Germany and went into the world, they took the Werkstatt concept, and this is the major thing of the practical education in the Bauhaus. They took it with them and they had to translate it into English, and they decided to name it workshop, not to name it the garage or the tool shop itself. And here I learned that workshop is neither a tool shop nor a little conference. It is the engineer's studio. So, and that was also from that point of view, just a new thought. Of course, I know the atelier. The artist needs an atelier where he can create his paintings, his sculptures, and so on and so on. That I, as an engineer, also need such an atelier, such a studio to perform my own work itself, expressed by the beautiful German word Werkstatt. That was also in my mind a new link that I at that time had more or less the right interpretation what workshop finally is. And that is, if you want to dive into the Bauhaus concept itself, you have to understand that this workshop, but in the meaning of the studio, the atelier of an engineer, that is the exact translation where you as an engineer can perform your work. And if your teacher is stepping by to look, okay, what are you doing? What is what you are creating? You do it in the workshop and you show your teacher what you have created in the workshop, and the masters and the professors are coming and you can show in front of your sculpture or whatever, you can show your creative arts. And that is more or less also for us as engineer, the important thing. We need also that workshop where we meet our students and looking at their practical work, and here make also the training in that, which is, if you look to modern education in German universities, far away from reality, what we are finally doing. So now the interesting thing is, and here we have to look a little bit to the time, because I gave you now a lot of slides where I hopefully have made good translations of words and thoughts coming from Gropius by himself. Of course, I do not have the time now to read all that through or to tell you what it is. I'm pretty sure if you have time, take a moment for that. It takes maybe half an hour, that you slowly, carefully go through these thoughts. I just go slowly through my slides that I say here, or that you see, okay, I give you in that slide presentation a lot of words coming from Gropius directly, where he more or less gives his philosophy, his thoughts, why he finally created the program I will show you now in greater detail. So it's very interesting to hear it or to read it from his own words. And then you will also find that his program he created at the Bauhaus itself is coming in to life. So I just invite you to go through these slides and read to that general words he were talking about that. The only things I really would love to read or to read loud for you is more or less his explanation or his concept description of his own study program. And he started, or the Bauhaus education starts with the preparatory courses. And here his own words on that was, sorry, I have to a little sip. The aim of the Bauhaus was to train people with artistic talent to become industrial designers, artisans, sculptors, painters, and architects. Well-organized manual training served as the basis, both from a technical and a formal point of view, with the aim of practical teamwork on site. The Bauhaus counteracted the fact that today's people are too much at the mercy of traditional special training from the very beginning, which can only impart specialized knowledge to them, but neither makes the meaning and purpose of their work nor their relationship to the environment understandable. That it did not initially place the profession in the foreground of the training, but rather the people in their natural willingness to understand life as a whole. The basis of this training was a preparatory course in which the student was made familiar with proportion and scale, with rhythm, light, shadow, and color through experiments. At the same time, this preliminary course allowed him to go through every phase of primitive experience with all kinds of materials and tools, and thus to find within the bounds of his natural gifts the place in which he could move with certainty, aimed at allowing intelligence, emotion, and imagination to flourish and mature. This 6 months training aimed to develop the whole human being who can tackle all things in life from his biological center with instinctive certainty and be up to the rush and chaos of our technical age. The accusation that such a general education is an extravagant waste of time in our world of industrial economy is, in my opinion, experience unfounded. On the contrary, it has been shown not only to give the student greater confidence, but also to greatly increase the productivity and pace of his subsequent special training. Only if a broad understanding of the interrelationships of the life phenomena surrounding him is awakened in him at an early stage, will he be able to make his own contribution to the creative shaping of his time. Since both the future craftsman and the future artist were subject to the same basic training at the Bauhaus, the basis had to be broad enough for each talent to find its own way. And finally, the concentric structure of the whole training concluded all essential components of design and technology from the beginning, so that the student should get an immediate insight into the whole field of his future work. The further training then only went into breadth and in depth. It differed from the elementary pre-education only in extent and in thoroughness, but not essential. The training in design began at the same time as the first material and tool exercises. And then he also made an explanation of, this was more or less on the formal side, but also now especially on the workshop training, which is always accompanied with that. Every student at the Bauhaus had to work in a workshop of his choice during the course of his training, after he had successfully completed the preliminary course. There he studied under two masters. That was an important information for me. Under two masters at the same time, a master of craftsmen and a designer. It was necessary to work under two different teachers, for there were neither craftsmen with enough imagination to master artistic problems, nor artists with enough technical knowledge to work as heads of workshop departments. First, a new generation had to be trained that was able to combine both qualities. Only in later years could the Bauhaus entrust the management of the workshops to former students who now had sufficient technical and artistic experience. Thereby, the original separation between masters of form and masters of crafts became obsolete. Technical training in the workshops of the Bauhaus was not the end goal, but an irreplaceable educational tool. The aim of this training was to produce designers who, through their precise knowledge of materials and work processes, were able to influence industrial production of our time. That's why we tried to produce models for industry that weren't just designed at the Bauhaus, but actually made in its workshops. The main goal was to create designs for standard items for everyday use. The workshops were mainly laboratories in which models for such products were carefully developed and continuously improved. And with this own word, can you explain now a little bit better the program you see here in this chart, even if it's hard for you to read German words? So as we said, Sub, can you tell me that? Do you see my mouse if I'm walking through that? Laser pointer. Now you should see. So the thing is, you see here, all the students started, and this is the outer ring, in this 6 months general preliminary course, where they, on a broad scale, just to play, and this is very important, they played and trained with anything, and you see it here in the so-called preparatory courses, in which they experimented with color, form, and material without any purpose. So just to find the right feeling on the material, 6 months. And then they started into a more detailed program, and here they had two masters. They had a master of forms and a master of crafts. The master of forms, in our day, we would call them the professors of that schools. They were responsible, and that you find here in this next ring, they were responsible more or less in the form studies, which is more or less the study program, the theoretical study program of the Bauhaus. And of course, if you look to the topics they have taught, so natural sciences and material and tools and so on and so on, this is of course correlated to the 7 workshops, which is now the atelier, where you can work with, for instance, metals, with wood, with stones, with glass, and so on and so on. So that means the Master of Form gave the theoretical study, and the Master of Crafts supported in the workshop itself that you get hands-on experience. And of course, you could assign yourself to one of the workshops or to more of those workshops. And this was also the very important thing from the beginning. The central goal, the ultimate goal of all artistic action is more or less the construction. So that was saying from the beginning. So whatever we are doing, our final ultimate goal is the construction at the final end. So, and only the very talented students afterwards then got the chance really to go on the construction side and to make their program. And
you finish in about 15 minutes, 15 minutes?
Yeah.
Okay, thanks.
So, and now just to give you an impression, this is the module structure we give to our students nowadays. Of course, we also have a module structure, but I just give you one statement of one of my students where I started to discuss Bauhaus itself. He said to me, Mr. Schulz, if there's one result of your Bauhaus activities, that would be really great if we can get rid of this module structure. And then I was asking why you want to get rid of that. He said, we are hating that module structure. And I'm asking, okay, what are you hating here? And he said, look, we do not know what we study. We do not know why we study. The only thing is what we know is we have to study that within 6 semesters, so 3 years. And if we fail, we are doomed. So this is more or less the statement of a modern student on our module structure, telling us more or less they don't understand what they study and why. The funny thing is, with my own study of the Bauhaus, in looking with neutral eyes or with student eyes on that topic, I could understand their program immediately, and they catched me on a very emotional level where I immediately decided I want to go and run into that study program. So, and here, this is how we do it again. So that is the starting program where we have, okay, you can read something. And especially here at the end, you see here, if you look to the module blocks, there's only one German word inside, Schwerpunkt module. That means that is a module of focus, where you decide to go into a focus program. Then you have a catalog. If you decide, for instance, into the focus program of microelectronics, you have a catalog, and here you see the catalog of microelectronics, and you have to select some of those modules to complete your study. This is the way we are doing that, and wonder why we do not attract people to our work. And then I decided, okay, and this is what I want to now run through and just give you an impression. And here you see about any bigger chapter of my talk, I could speak easily 2 hours really to explain everything. I now try to say, okay, I want to try this concept, make it better, and let's have a look. Can I attract more students, or can I be more productive and more successful in my training if I try some sort of adaptation of the Bauhaus concept to my own work? And therefore I said, okay, Gropius and the Bauhaus started with a manifest. Let me also start with a manifest. But now of the microelectronics Bauhaus, I want to give the manifest to. And of course, I have first to answer the question, okay, what is the ultimate goal of semiconductor engineering and technology, or just in one word, microelectronics? And I would state, okay, the ultimate goal of semiconductor engineering technology is the manufacturing of the semiconductor chip fulfilling the specified electronic functions and operations under predetermined parameters. But this requires an in-depth study of the 4, at the moment, the current semiconductor technologies, which is bipolar, MOS, CMOS, photonics, and quantum. Then this also requires the development of a profound understanding of the electronic, mechanical, chemical, and thermal properties of semiconductors, insulators, and metals, and a deep knowledge in circuit concepts. And finally, in the concepts for the heart of any semiconductor chip, the electron semiconductor device. And the whole study program, which more or less gives the form theory of our microelectronic Bauhaus, is accompanied by workshops for the development of craftsman skills in microelectronics and technology. All in all, we can state that therefore the aim is to train young engineers, young master engineers who are capable of inventing, developing, building, and testing semiconductor devices for the following fields of applications. And you can read here what I mentioned here, which is now explicit for my subtopic of. And then I decided, okay, I give a general headline to all my education, and this is what I now since 4 years permanently tell my students, that the electric light was not invented by further developing of candles. So this is more or less the driving force we also have to develop, that we try to reach for some sort of utopia and try to find something new. And here we have now, as students and teachers, have to form a new community in training and education. So that's why I tried to define the community of the microelectronics Bauhaus, and I decided that this consists of the trainees and the workshop students of the subject-related bachelor programs. These are the apprentices. The microtechnologists and the workshop students of the subject-related master programs. These are the journeymen. The technicians, which are the masters of crafts, and the doctoral students, which are the masters of forms of the microelectronic Bauhaus workshops, and the senior masters of crafts, the senior technicians, which are the senior masters of crafts, and the PhD graduates and professors, which are the senior masters of forms. And one very important thing is that the whole program has is more or less, or is coming from the desire to produce the new component, the new design, the new electrotechnical system, which finally means preparing and promoting the disruption in our field of expertise. And of course, this all must follow, taking ethics, preservation of creation, sustainability, quality, and reliability, and the optimal design, of course, and much more points into account. Just to show you my hall of workshops, so this is really my big tab where I have now the individual workshops of the semiconductor engineering training for my students. And here maybe I rush through. Of course, I also decided to make some special programs, like for instance, the marketplace of ideas, where also especially young students are able to bring up an idea and to go into the workshop. And here I also defined under which criteria you can join our workshop. I will not go into that much detail due to lack of time, but if you have time and if you're interested, you can read it more carefully afterwards. I describe. So all in all, we have now in our microelectronic Bauhaus 2 parallel paths of education and and training. On the one hand side, we really have an apprenticeship program in microtechnology. And here the stations you can reach is the apprentice, the journeyman, the technician, which is finally the master of crafts, and the senior technician, the senior masters of crafts. And we have in parallel the academic study program, where then our students are workshop students if they are on the bachelor level, workshop students if they are on the master level, workshop students if they are on a PhD level. Here they are becoming the master of forms, and if they are graduate, then they are the PhD graduates, the senior master of forms. And I took the idea of the Bauhaus that now all of my students get 2 masters during their education. So my workshop students on the bachelor and the master level of the academic program are always have a senior or a master of crafts and a master of form as direct mentors and partners in their practical and theoretical education. That is then later on also true for the workshop student on a PhD level, But here they have 2 masters of crafts and forms, but they are definitely on the senior level, which support their work, their research work, mainly also in the workshop. And of course, that is also true. And here I also make a link. So in this concept, you find a double link, because also the ordinary apprentice in our apprenticeship program gets, of course, a master of crafts or senior master of crafts as an advisor and as a mentor. But we are also linked that to our study program, because especially the PhD students are the master of forms on the PhD level and on the training level. They are the mentors and the supporters also for our apprentices. So that with this, I can link both paths, the academic path and the apprenticeship path together. And we are all, if we are reaching higher levels, are all responsible for the training, the theoretical training, as well as the practical training of our students. And of course, now I'm also asking now the question, and I just give you that as a short information. And you will also find here a lot of slides you can go through if you like that. I also asked myself the question, okay, in which way I have now to prepare my lectures itself to motivate and to attract more students, which coming from different fields and different interests, and how to do it, that if I have a bunch of students from different fields, how to attract them all to deal microelectronics. That means in one lecture, I must give a program where all of these students from the individual subjects see a link to their own vision and view of their personal life and their study program, and give a motivation why they should start to go study in microelectronics. And here I found, and this just an information for you, here I found, interestingly, from the same period of time, and very interesting approach on a psychological level. This is the so-called cultural historical psychology, where the cultural historical activity theory is coming out, which is mainly coming from Vygotsky, and later on was further developed by Vygotsky, Luria, Leontiev, and Galperi. And this, here I also gave you the Wikipedia information, what more or less the Vygotsky-Luria circle of people who developed that theory is. And if you like, here you see a little bit more information. What are the major terms and what are the major ideas in that activity theory, mainly here. And this is just an information for you guys. Here I found for my own work, but here I would need at least 1 more hour to explain you that in greater detail. I found a lot of information how to work in my lectures itself to attract a multiple field of students for electrical engineering and semiconductor technology. And especially here, I'm now on that level, and maybe in my next talk, I can tell you that in greater detail, that I tried the so-called stage-wise development of metal actions, which was developed by Galperi, and it's in total 5 stages you have to do with your students to bring them to the next level in training and education and knowledge. This is what at the moment is my work, that I go over my lectures itself to look in more detail also with that concept, how I present the knowledge and the facts in my lecture time. So just to make it short, it is always this 4 words you have to follow. You have to create the lecture in a way that first the student understands, then have a task to analyze, use it, and to transfer it to some new knowledge. And this is what I'm at the moment working on, to use that concept and go carefully through my own lectures itself. So, and of course, this is now has also some impacts on my own lectures. That, for instance, I started at the beginning to discuss with my students, okay, if you join me and if you learn semiconductor engineering and technology, what finally you can learn, and you want to become a master in a certain subject, here I define what finally you can do if you study my program, what mastery you finally gain if you study my program in the Bauhaus. I skipped that. And the funny thing is here, for instance, I learned And this is what I'm doing now since years, that I learned it is much more easier to train students in the following way, that the funny thing is, to understand semiconductor physics and semiconductor engineering, you have to focus on the central device effects and physical phenomena which are running into a semiconductor crystal. And the funny thing is, and you see it here in the blue boxes, there aren't so many central device effects and physical phenomena. And the funny thing is, you can easily train the students the phenomena effects, and then just give examples how to use these effects and physical phenomena in typical devices. And then, of course, the training is performed in a way that with the effect and with some examples, the students are finally then to transfer to similar devices which are new to them, but they have now all the knowledge to understand how this device is working. And if you also look to my study program, in total, I have 3 lecture series: the classical semiconductor engineering series, which is mainly dealing with the 2 concepts of the emitter effect and the field effect, which covers more or less the whole modern classical microelectronics. Then I have a semiconductor engineering series on quantum itself. Here we need a little bit more effects, but this is covering the whole story of modern quantum technology, semiconductor-based quantum technology. And then I have a detailed technology series of lectures where I describe how to produce these devices, how to manufacture devices. And later on in the workshops, they are trained in the techniques and in the tools and in the machines to build these devices by themselves. And a little bit more to illustrate, if I said, okay, we learn and we analyze and we use and we transfer, that I always in the lecture try to fulfill the following scheme. If you look to a semiconductor device, the semiconductor device always has a certain crystal structure. A certain physics is running the device. And finally, as an electrical engineering, we have some electrical characteristics of the device. And what I permanently start now to train with my students is that my students must be able to look on semiconductor devices in the 3 ways. If they are knowing the structure of the device, and if they understand the physical phenomena and physical principles, they are able to derive the characteristics theoretically without measuring it. If they know the characteristics equipped with the physics behind the phenomena, they are able then to extract the relevant device, what is the crystal structure, what is needed to create that. And finally, if you know the crystal structure of the device and the characteristics, you know exactly what physically is running into the device. And now I go all to my lectures in this way, that I permanently train my students always to look in these 3 ways onto a semiconductor device. And my feeling is that now the students start to understand much better what's really going on in semiconductor physics. And of course, there's always a design theory. And I also stopped presenting my lectures in number 1, number 2, number 3, number 4, please attend these courses, that I explain my student the general design path from a first idea of a semiconductor device to the prototyping device has always these 5 stations, and more or less my lectures are now assigned to this design process itself, that the students immediately know, okay, I'm studying now this lecture. I know I learn now on this development path, I learn now knowledge on step number 4 or step number 3.
Can you try to wrap up? Yeah. You're almost.
So maybe I can skip that. That is just, and this is now my...
We'll invite you to another lecture, follow-on lecture. That would be lovely.
My last question, and this is the end of my lecture today, is it's very nice, but it's still the open question, how to attract the youth to that program. That is still an open question. And I have to prove that my concept, if I also now present the concept to a broader audience, can attract the youth. And the funny thing is, and I still stay in the period of time of the 1920s and the 1930s, and this is my latest hypothesis I'm now trying to test to understand better youth and maybe to get here an access to find a strategy also in future to attract youth to our programs. Because if you look to the so-called Kondratiev waves of economics, then, and this bright guy here in the mid of the 1920th centuries found out that our economic world follows these big waves, which are lasting at least 50 years, where some major technologies, some major developments, ideas, and inventions formed a whole industry. And if you look, our modern industry, for instance, in Germany, is still based on the automobile and petrochemicals itself. Of course, information technology, that was the fifth Kondratiev, but this is already gone. We are now here at the beginning of the so-called sixth Kondratiev, where no one really knows, okay, what is now the next wave? What is the big story behind? My observation on these Kondratiev cycles are, and this is just my hypothesis I want to explain to you, is these red stars you see here mark 2 or 3 stations of my personal life. In the 1990s, I started my study, my own study at the Technical University of Braunschweig. In 2008, I started my first professorship at the University of Stuttgart. And since 2021, I'm here in Erlangen at FAU. These are on the time scale with the 3 stars. And you see, I started my study at the beginning of the fifth Kondratiev, the information technology. I started my first professorship in Stuttgart at the end of the fifth Kondratiev. And now I started my work in Erlangen at the beginning of the sixth one, where no one is really knowing what's going on. The funny thing is, if I remember myself, my generation at that time, we were looking into the future. We were studying electrical engineering with respect to information technology, computer design, all that stuff. But we all had a car. It was a must-have for us to have a car. So the technology coming from the Kondratiev before, this was our must-have to have that. But we haven't studied that. We were looking into the next cycle itself. That was the study program we were looking at in our times, information technology, computer science, and all that stuff. The funny thing is, as I started in Stuttgart 2008, no one of my students were interested in having a car. A lot of my students even have a driving license. This was in my time an absolutely no-go. Yeah, we all have a driving license. Most of my students don't have a driving license and they don't want to have a car. What they have is the best smartphone in the world. Most of my students have better smartphones than myself. So also here, the funny thing is the must-have is the technology coming from the Kondratiev before, and they were looking into the future. And at that time, yeah, maybe energy and renewable energy, that was the hype. They were all studying renewable energy. Now we are here in 2008, and I'm pretty sure if we want to attract students, then we must sure, okay, the technical must-have is coming from here, but we have now to find out what is utopia in the future, because our students have that. And maybe it's not only the green technologies for the climate change or for e-mobility, it is also health. Yeah, our youth is addressing health. And now not only to get old in a healthy way. This is what they are focusing on. And I'm pretty sure if we don't look in our own work into that utopia, and if we don't express our work towards that utopia, they will not come. So that means for me, I have now to find out, okay, what I believe in the sixth Kondratiev wave is coming to present semiconductor technology in that way. But then I have to prove that it works. That would be the proof of my hypothesis. But at the moment, it is just a hypothesis. And that was the last thing I wanted to show. You see, and the only thing, and that is my final statement, was this definitely for sure a last word from Gropius himself. The mind is like a parachute. It can only function if it's open. Yeah, this is maybe also a good final word for my lecture for today. And now I thank you for your attention.
Thank you very much, Joerg. Really, it's a wonderful lecture. And I think it is very important that you brought the past back to the future in a way that we could really relook at our own thinking and our own way of teaching. So with that, I will open it up for questions.
Joerg, thank you very much. I think I can relate to a lot of points that you have made. Maybe I'll reach out to you separately to exchange notes on this. But the whole core principle of Bauhaus and trying to absorb that into an engineering program, it's a phenomenal activity that you have done. One question I have is, one of the core philosophies of Bauhaus is to develop more like an all-rounded individual, right? By giving them exposure to different domains and things like that. So how are you trying to bring that into your program? And the related question is, what is the typical class size that you are dealing with for this kind of intervention?
Maybe I start with that final question because that is the easier one. In the basic courses itself, the basic course on, for instance, semiconductor devices, all electrical engineering students must attend. And here we're talking about a group of 100 students. But of course, not all of them study then microelectronics or go into that focus program. This is how many students finally you attract. You then later on see starting in the 4th bachelor semester, where I start my lecture series, which are then in the focus program. And here the starting lectures of all these series, so 4th semester bachelor, we start typically between 20 to 40 students. So that is the class size at that level. Later on, if we go to the higher classes and then also in the master program, this is dropping down to 20. And if I go to my absolute high lectures at the final end, we are talking a group of, let's say, 5 to 10 people. So, and now, of course, not all of them now then later on are also coming to our institute and want to perform their bachelor work and master's work. The funny thing is, at the moment, we are still see a climbing up of numbers because here in Erlangen, I'm just here since 2 years. Before I came, the chair was fully empty, so that means no student. So within the 2 years, we started more or less from 0 students in our workshop. And now, meanwhile, we are climbed over 20 and heading in the direction of 30 students, which are now coming on the different stages, bachelor, master, and master thesis work, and now also the PhD students. So all in all, I would state now on a PhD level, if I also now take Fraunhofer into account, we have at the moment 45 running PhD projects, together with roughly 25 students on master and bachelor level. And the point is always that we already start in the bachelor, so they come and they want to do something with us. They want to continue also the practical work. And we also have workshops, because if you look to the manufacturing scheme of a whole semiconductor chip, you have certain technology areas you have to learn, machines you learn. And in the bachelor level, we just ask, okay, what is your philosophy? Where do you finally want to go? What do you want to learn most? And then you are assigned to the workshop. And here the idea is that at least in the bachelor level, you start to learn at least one technique, one tool. And then later on in the master's, you can stay in that workshop, or you can change the workshop to learn more tools from another workshop. And of course, my expectation for those who stay longer with us, especially in the PhD program, I expect that they are using the bachelor and the master program to visit more than one workshop to learn more tools and technologies, that then in the PhD, we really can assign a topic to them they are fully able to do by themselves in the workshop. Yeah. Of course, the final product of everything we are doing is a chip. Yeah. And the question is always, we are asking, okay, in which direction you think you want to drive your life, and for what the chip you want to design is good for. Yeah. And then you decide, okay, what do you want to learn? And then we train that to you to bring that into life. And the good thing is the big facility you see, the big cleanroom facility is run by technicians and by craftsmen, which are special trained and which are here now for their whole life, for their whole working life. And also here the concept is in a classical academic education, you have, let's say, the PhD student is responsible for the master student is maybe taking care for the bachelor student. So that is the mentorship. I now also assign our craftsmen in the workshops itself to become mentors and to train our students. So that is really a link between the apprenticeship program and the academic program. Hopefully that answers a little bit your question.
Another question is, did you have to change or restructure your labs to enable this workshop type of model?
It is more or less already given. The funny thing is, the workshop, the big cleanroom facility is already organized in a workshop structure. So that was not coming from me. So I just had now the different look on the problem after looking into Bauhaus and realized, hey, look, in the way we are doing our job here in the clean room, that is, we have individual workshops. Yeah, we just have to. So that's why maybe that is also the thing why it catched me in the way. I see so many parallelities between my work and the thing we organize ourselves, and that what I learned in the Bauhaus. The funny thing is what I learned, let's say it that way. It's not that I followed a certain strategy. I found Bauhaus and now I change everything that it's running like Bauhaus. I tried over the last 25 years a lot, and Bauhaus now gave me a complete frame. Now it makes sense what I do. And by training, I found out this is working, this is not working. And I had no clue why it is not working. Now with this frame, I understand now why some things are working and why some things aren't working. And now with the help of Bauhaus, I can complete my own structure. Because there were still open points, I can now perfectly fill and to complete my own picture. So that is what Bauhaus gave to me. So it's not that I discarded everything and started from scratch in a new way.
Reconstructing them.
Yes, some, yeah, and it was a big enrichment of my own work. What came from Bauhaus into my own work.
As Joerg said, he can talk about these things for a couple of hours because he has gone through so much of this thinking. We are already way over time today. I will invite him again to talk more about the details of how he set up the program. Yes, please, go ahead.
Yeah, so my question is that what's the actual difference between a Bauhaus and a Hochschule? Because as you see, in a Hochschule, the internship or the practicum is mandatory. And most of the German students, instead of going to Gymnasium, they actually go for the Hochschule, like what the professor said right now. So was ist die better Idee? Ist es die Ausbildung durch Hochschule oder Gymnasium?
The point is, both concepts are, if you look what we have to do, both concepts are wrong. If I look to the actual program at the universities here in Germany, we have an excellent theoretical program enriched with practical work, which is, to be honest, in 80% not really relevant. Practical, that is not practical work. Even if we have lab work or something like that, this is far away from practical training and experience. On the high schools itself, on the Hochschule, you have the other way around. Here you have much better professional training, craftsman training, but the theoretical background is very, very small compared to that what is given at the university. Bauhaus itself managed it in the way to bring it together. The deep theoretical program of the university and the practical training coming from the Hochschule. It's, let's say it that way, Bauhaus in this philosophy is a perfect mixture of what we have in Germany, the Hochschule, on the other side, the universities, bringing the two perfect sides of each university in one together. That's the story behind.
There is a question here, but I think that requires a very long-winded answer, and it is culturally determined. It says, how does one convince academics in engineering that art and craft are equally important? I think that requires an hour's answer.
The point is,
if you want, you can attempt a quick answer.
A quick answer, you don't have to convince the people, you just have to show them. And then students are catched. I have that experience. It is not, we have to convince all, now also focus on arts and crafts. You have to live that, and you just have to show the students. And I learned, at least that is true for my students, they follow and they love it and they start to look in detail. And the funny thing is, since I started on Bauhaus and talked to my students, they are running in the world, and I get WhatsApp messages when they are on vacation and find a Bauhaus architecture. I get a pic. They are telling me, look, we found Bauhaus, where I just realized my people are going now with open eyes through the world and look to architecture. They just do it. They just do it. You don't have to convince. Just show them. You by yourself as the teacher have to live it. You have, that's the only thing you have to show, is that it is also important for you. Yeah, you have to show crafts and art and science. That is much important of my life and so on. And then you will see students will follow and students will copy. You don't have to convince.
With that wonderful message, you have to practice what you preach as well as live what you are trying to convey. I think it was with that last message, wonderful message of yours, we'll bring this lecture to a close.
It was great to be in India again, even it was only virtually. Bye-bye, guys. Have a good night.
Thank you very much. Bye.
Bye.
Bye.